Welcome to the Links Fundamental Training. In this video, we will go over the basic principles of links to allow you to start your links development as soon as possible. Before diving into the practical elements of this training, let's first look at some basic principles. Starting with asking the question, what is Links? Links is a low-code development platform that can be used to create integration, automation, and nearly any back-end application at speed. The development philosophy of Links is to put you in control of the development efforts. This means that you can develop with high degree of flexibility and customization while still doing so at a high level of abstraction. Examples of things you can develop with Links include APIs, integration applications, automation applications, middleware, data management applications such as ETLs and ELTs, and more. Links is also a low-code application. Low-code in Links means that you code at a higher level. No syntax bugs or complicated long code blocks. Most pieces of logic are created by dragging and dropping them into place and then configuring them afterwards. Although Links is a low-code application, it follows the same structure as traditional coding. Think of Links as coding in bigger blocks or coding without having to physically write code. There are some similarities between traditional coding and Links, for example, the use of functions, parameters, and services. This image shows how a traditional code block will be translated into Links. In the C# code, we see that there's a function called addNumbers. This function receives two parameters, both integers, number 1 and number 2. It then adds those two and returns an integer value back out. Inside of Links, the same thing can be created by creating a function, adding the numbers together in return, and by adding parameters. We'll go over the Links Designer in more detail in the next section. Now let's look at Links as a platform. Links has two parts to it. Number 1, the application designer. In the Links Designer, you will build your application, test it, and make sure that it fulfills all of your requirements. Once you're happy with your application, it will be deployed onto a Links server. The Links server will host your application and will monitor for any issues that may occur. The Links server can be hosted in the cloud or on-premise based on your requirement and available licenses. Here's a better illustration of what the development process is like inside of Links. Inside of the Links Designer, you will build your application, then test it via debugging. Once you're happy with it, obviously it's saved. The saved files will create solution files that can be uploaded onto something like GitHub or Bitbucket. Once you're happy with your application, it's then deployed onto a Links server, where it is hosted and monitored. You can add in things like orchestration, such as timers, job schedulers, all of those different type of elements onto your solution, and these orchestrational tasks will be carried out by the Links server. This means that the application will execute on the server without human intervention if it was created to do so. A Links application has a few basic elements to it. We will be going through each one of these elements in more detail later. However, the major components are a solution, plugins, and then various solution elements such as functions, types, and services. A Links solution is an application that solves a business problem. It is a container comprising various elements like processes, services, data, and logic components required for your application. The scope of a solution can be as broad or as narrow as you need it to be. A solution can be as large or as small as the business case demands. For example, some users create a solution for each business unit, while others create a solution per project. In short, a solution is an application created by Links that executes logic and functionality that you configured. A solution will contain all of the logic that makes your Links application work. Next up is plugins. Plugins contain a set of pre-built functions, types, and services. Each plugin is specialized towards handling specific data types such as JSON or CSV, or specific technologies like cryptography, databases, or REST. We will look at plugins in more detail in the next section. For the next section, I'm going to switch over to Links Designer to show you the elements such as functions, types, and services in a more practical manner. This is the Links Designer. The Links Designer is a low-code IDE. Let's now go over each element of the Links Designer to understand what we are going to be working with. On the left hand side over here, we have the Solution Explorer. The Solution Explorer will contain each element that we create inside of our link solution. This will contain the basic logic, application structure, data structure, and services for our application. As mentioned, the basic building blocks of links is functions, types, and services. Service can be something such as a timer. Let's go over each one of these elements to understand them a little bit better. Starting with a function. Functions are the basic building blocks of a solution. Functions are reusable processes that hold the application logic. This logic executes basically any backend functionality. Functions comes in two different types of varieties. Number one is user-created functions. These are functions that the user creates that contains user-based logic. We can add as many functions as we want into our link solution. The logic is then added in here in this section that we call the central canvas. We drag and drop elements in here and then configure those elements to make sure that it will execute the logic that we require. The second part is plugin functions. These are functions that are pre-created that contains back-end functionality. When I click on Add Plugin as an example and we click on something like the Database plugin, the Database plugin will be installed on my solution. Now that it's installed, over here there's different functions that I can now drag into my application. For example, something that will be commonly used is the Execute SQL component. This component allows me to interact with databases by adding a connection string and a SQL script. It is important to note that user-created functions are reusable. So as an example, let's say inside of this function 4, I want to use function 1, I can just drag and drop that in there, and then I can add the parameters that I need to add. Next up is services. Services include scheduling, monitoring, and triggering of events. These services are highly flexible and scalable. Some services include a timer, REST host, directory watch, Kafka, RabbitMQ, and even a job scheduler. Typically, a service has an event handler where functionality is added. Event handlers or events will contain the logic to be executed when a specific event is triggered. These events are then taken care of by the service. As an example, this timer service. This timer service is set to execute every minute. It's set on interval, so it will run every minute. And every minute, the events inside of this timer event will execute. Now we can do something like build some of our functionality inside of a function, like as an example, this function that we just created here, and then drag that function inside of the event handler. This means that every minute when this timer executes, the functionality inside of this function will execute. Different services will have different event handlers. For example, the REST host service will have an event handler for every operation or endpoint. Think of event handlers as functions that are executed when an event is triggered. The next basic component of links is types. Types are data objects and data structures to store and easily manage your data. This data can be accessed, managed, and manipulated in various ways inside of your solution. Think of types as visual representations of JSON objects. As an example, this type. When I open this up, nothing has been pre-configured as of just yet, but we can add in things such as user details. Let's add a name, surname, identity number, and cell phone number. If I save this, this type has been created. We can also rename it to person. Now we have a type that contains our person data. Links has two different types. Simple types, which are base types that typically have a specific value. Think of these types as variables. These types include string, binary, integer, datetime, lists, and more. These types can be found here on the plugins tab. As an example, I can drag in this string element in here, and then we can assign a string value to that. They function exactly as variables would in more traditional coding. Secondly, there are custom types. We've already created a custom type with our person type over here. Custom types are created by you. These types can be as complex as you need them to be. Typically, they contain a set of simple types or lists, and these lists and types can contain even other types or objects that can create a very, very complicated structure of data. These types can also be created by importing them. For example, If you have a JSON object, you can import the type into your solution. For example, I have a very simple JSON object that I need to import. I can right click on my solution, click on import type. We need to give it a name. We're going to call this product. Paste the JSON object. Click on create and product will be created. Inside of product, each one of its properties are also created. You can create quite complex types. For example, when working with REST APIs, you might be working with a more complex response body or request body that you need to send. That is essentially the 4 elements that you will be working with inside of the Solution Explorer. I'm just going to clear out my Solution Explorer and only have the function inside of here. Underneath the Solution Explorer, we have the Properties tab. The Properties tab is where we set the properties of any object defined inside of links. As an example, let's say I want to use this execute SQL component in here. This specific component will have various properties, including the name, so we can make it a little bit more easier to understand what it is or to recognize it. But underneath that, we have the properties that will differ for each component inside of links. Let's take a look at something like this string component. The string variable over here will only have a value property. However, the execute SQL properties are a lot more configurable and a lot more in depth. Here we have things like a connection type, which can be Oracle, SQL Server, ODBC, or transactions. We have the connection string, the SQL, the timeout, and the return type. For the string, we only have the value. Next to the properties tab, we have the central canvas. This is where we're going to create the logic of our application. In here, we drag and drop various elements to build up our application logic. It is important to note that the logic will be executed from the top downwards. Think of this as how code will execute. Each element will be executed. So in this stack, the first thing to execute will be the execute SQL component, then the string, then the return, then the try catch. Although this specific combination doesn't make any sense, it does illustrate the point that if you want to exit out of a function at any time, you can just use something like this return. Underneath that, we have the validations tab. The validations tab will tell you whether or not there's any validations that has failed inside of your link solution. Think of this as things like, as an example, our SQL is required for our execute SQL component, and we also need a connection string. It'll usually indicate the path where that error is occurring or where that validation has failed. For example, this specific issue occurs in function, which is there, execute SQL, which is this specific component, and then the connection string, which is this specific property. You can see the various paths of the various validation errors that occur. On the right hand side over here, we have the plugins tab. The plugins tab is where all of the plugin functions will sit. We can click on this button to add additional plugins. Links has a wide variety of plugins to choose from, as an example database, email, Excel, file, FTP, and more. Another component inside of links is called a setting. Settings are universal read-only parameters that can be used throughout your solution and can be changed for different environments. Settings are especially helpful when you repeatedly need to refer to a specific value, for example, a connection string, a file location, URL, or anything like that. Settings can also be made secret if you need to store a confidential value such as an API key or password. Settings are really useful, especially when you have multiple environments with different connection strings or different APIs that you need to call, because the setting can be changed on the links server. They are not hard-coded, so they can be configured on the link server to point to a specific value. As an example, let's create a setting called database connection or DB connection. This is going to be a string. However, it could be a boolean, a byte, a datetime, decimal, double, integer, or string. And here we can add in our connection string. The value can also be made secret if it is sensitive information. Let's talk a little bit about flows and properties. As with any application, a process is built out of multiple functions that execute specific logic. A key part of these executions is data that will need to flow from function to function. This flow of data is facilitated by parameters and results. In programming, a parameter is like a setting or input that you can give to a function or a program so that it knows how to perform a specific task, allowing you to customize its behavior and get different results. This is also true in links. Results represents return values from a function. Plugin functions have predefined results that are shown in the definitions panel. The results of a user-defined function are also user-defined. What does this mean? Well, if we look at something like my function over here we have parameters and results. As we already said, when I open the parameters tab over here, I see all of the parameters that will be my inputs. So we can have something like ID if I'm working with something specific, or number, or anything like that. Let's take a function where I'm going to take two numbers and add them together. So let's do number 1 and number 2. Both of these will be integer values. It is important to note that the type that I enter in here can be as custom as I need it to be. So let's save this, and let's say I have something specific like a type. Let's say we have our type person again. Type person has a name, surname, and a cell phone number. I could, if I wanted to, add in person and add person as a whole type in here. I could also, if I wanted to, add a list, and that specific list could be of type people. That means that I am now passing in a list of objects called person. But for this example, let's keep it simple. Let's stick with our number 1 and our number 2. That is for input. Now for output, we're going to work with what we call results. Results is essentially the result of a function. So if I open up here, we can have a specific type, or we can create a custom type if we wanted to. By creating a custom type, we can create a very complicated result if we needed to. And as the same with the parameters, these can also be objects that we created, types that we created outside, or list of types even. Let's stick with something simple for this example. Let's stick with a very simple integer. Now to create this function, I'm going to use this return because we need to return a result. And the value over here, I'm going to open what we call the expression editor. The expression editor is useful to create expressions that will execute basic logic. We will focus a little bit more on this in the next section. But for this very simple function, we're going to take the variables, which is coming through from our parameters. We're going to take number 1 and we're going to plus number 2. So number 1 and number 2 is going to be added together. We're going to say OK, and that's our return. Now, if we wanted to test this out, we can debug it. I'm going to right click on this return, add a breakpoint. What that means is that the application will execute up until that point, and then it will stop there, and then it'll allow me to basically inspect the data that's coming in, data that's going out, see what's happening in my application, and then I can move on from there. I'm going to debug. Debugging will create a locally hosted version of this function. It will compile it, and I can now add in the numbers here. Let's add number 1 and number 2. So if these two are added, it should be 3. So if I click play, there we go. The application stopped. It hit the breakpoint. Breakpoint reached. Return. We can now inspect the values on the right side over here. Number 1 and number 2. Number 1 is 1 and 2 is 2. And if we step over this, we see that the result is 3. Step out. Over here we can see the function result is 3 and the function finished. So that in a nutshell is how you're going to work with properties inside of your link solution. More complex components might have more complex results. As an example, let's see what happens when I read a simple file. I'm going to create a new function. We're going to call this function read file. And for this to work, we're going to have to add the file plugin. I'm going to add that in. Over here, I'm going to select text file read, drag that in there. We have to give it a result. We have to give it a file path. We can also select this file path if we needed it, but let's just add that in there. The return option is going to be line by line. Let's change that to be a list of lines. Now let's define the fields. For the fields, we know that it is delimited by a semicolon. We know that we have one header row. Let's load this file up there. We've now loaded the headers from the file itself. It has ID, name, price, and quantity. We can even see what the data will look like. There's how it looks in the text, and that's how it looks formatted. Save that. Now we've effectively created a very simple file reader. But what we're interested in is we're interested to see what the data is going to look like that comes from this file. So if we click here on this definitions tab, we can see exactly what it is. We can see that there's going to be a list of rows that's going to be returned, generated, and each row contains an ID, name, price, and quantity. Again, if we right click on this and add a breakpoint, debug this, and step over this, we can now see there's 100 rows in here of 160, and we can see each one of these rows and see the data coming through from it. We can now use the data coming from this component downstream in any way that we need. As an example, we can read it into a database. What is important to note is that each plugin function is slightly different and will require a different configuration. However, you can clearly see the configuration in the documentation for that specific component. As an example, next to every plugin there is this little I button. You can click on that and that will open the documentation for the specific plugin. You can also click on the I button next to a specific component and that'll open the documentation for that specific component. As an example, this is the documentation for the execute SQL component. All of the documentation is there. So if you have any questions, feel free to look at the documentation or ask on the Lynx community site. One feature that is commonly used inside of Lynx is called expressions. Expressions allows you to access, manipulate, or even apply validations on specific fields or on data as a whole. Lynx comes with an expression editor that allows you to create such expressions. You can also use the expression editor to edit values using built-in Lynx functions, or you can use more complex expressions to facilitate more complex logic checks via conditional statements. As an example, let's create a very simple expression that will concatenate various values into a single string. For this example, let's say we have a name, and that name's value is Lynx. We have a surname, and this value is demo, and we're going to have a concatenation string. Now, in order to create the expression, we're going to have to open what we call the expression editor. To do that, I'm going to click on the drop down over here and then select expression editor. This is the Lynx expression editor. It allows you to basically craft expressions that will apply specific logic on a field. Over here, we have the variables. Now, variables are basically all of the variables that are available inside of this specific function. These are things that we've predefined, such as our common variables or our common types, as well as our custom types that have been dragged in here. We also have access to things like the parameters, input parameters that are available inside of this specific function. Underneath that, we have the system function, the system variables. These include things like the current date time, new line, and nulls. Underneath that, we have functions. Now, these are built-in Lynx functions that will allow you to craft more complex expressions. Since we're going to be using the string functions, we can look at what is available in string. We can look whether or not a string contains something specific, and on the right-hand side here, it'll show you how to use this specific function inside of your expression. We can see what is the index of something. We can also check the length, do some pad left, pad right, substring, and a host of other different functions is available for us. For this specific example, let's keep it very simple and simply concatenate the name and the surname. To do that, I'm going to add in the name and I'm going to plus the surname. Now, if I wanted to see the result of this expression without running it, I can do this by going to the test tab. Over here, we're going to have the inputs. The name is Lynx, and the surname, oh dear, Lynx, and the surname is Demo. If I run this test, there's our concatenated string. Now we can see that we require a space in between these two, otherwise it's going to be mushed together like that. So I can simply add a space. And if I test this once more, now we have links demo. If I wanted to add something in front of here, we can add something like this person is. And now if I test this again, there we go. There's our output for this thing. I can click on OK. And if there are any validation errors inside of my expression, they will pop up here. As an example, let's say I put in a comma over here, which is not expected. Then the validation there will be that there's an issue. And underneath here, expression contains invalid syntax. And it'll show me in the path which specific expression is the issue. Expressions can also be a little bit more complex in nature. Let's say I have something that I want to format with. Instead of using this structure, we can do something like this. This person's name is 0 with a space 1. And then we can use the format with function. Just double clicked on that. And to use this format with function, we can see that 0 and 1 is the variables that we're going to replace in here. So let's use the variable name, comma, surname. Now if I run this, links demo, run this test, this person is links demo. This is just a neater way of concatenating or building up a string if you want. But if you don't have these values available, then you can concatenate it as normal without any problem. You can also do other things. So as an example, let's say we are working with a decimal. We can do 2 double, 2 int, 64, or 2 string. Let's say we wanted to add the date to this specific string. We can say plus, and the date is plus current date time. Now if I run this, the person is links demo and the date is today's date. There's our specific timestamp. Now I'm not very fond of this format, so what I'm going to do is I'm going to use the built-in links expression for date times. If I can just find it, there we go. And I'm going to use the toString expression, and over here it already gives me that format. Now I'm only interested in the date, so I'm going to remove the timestamp. So let's test this out now. This person is links demo, and the date is, that's the date. So we've done two things now here. We've applied various different expression functions to apply some transformation on data, but we've also combined them. So over here we have our format with, then we have a concatenation, then we have the datetime expression as well. So you can see that you can chain these expressions, and as long as they run, the output result will be guaranteed. So if I now run this, I'm going to add a breakpoint, debug it, play, step over. There's my links demo coming in there. This person is links demo, and there's our expression. If, for example, I wanted to add an additional thing in here, let's say I added a string, let's call this name check. We can also do things called conditional expressions. So what a conditional expression specifically does is we can apply a little bit of logic to apply some specific transformations based on the value of something. So let's go into the expression editor. We're going to do the name. If the name equals null, then no name, else use name. I'm going to save that. And in my concatenated string, what I'm going to do is I'm going to replace name with name check. Now, if I run this with the value links provided, the person is links demo. But let's say I do something like remove the person value there, the name value there. Now it will be a null. We can already see that the name is null, surname is demo, and the name check is no name. So if I now go over this, we'll see the person is no name demo and the date is that. So we can apply these conditional expressions as well to do specific things for us. These are extremely useful in cases when you're working with objects that contains null and you don't necessarily know what to do with them. It's important to note that links expressions can also be used for mathematical equations. You can add things together, subtract them, multiply them, divide them, and so forth and so forth. That was a basic overview of links expressions. This is the LINX server. On the LINX server, all of your solutions are hosted and monitored. Each one of the items over here that you can see is a LINX solution that is now running on this specific LINX server. If I click on something, as an example, this demo integration solution, over here you'll be able to see all of the services running for that specific solution. This one has a timer that executes X amount of times per day unless it's forced to execute. I can also see the settings over here. Over here is where we will change the setting values. Remember that I said that settings can be changed on the LINX server. This is where those settings are changed. I can see the entirety of the solution, meaning what components or what it has. This one has the getData function as well as a timer solution. And I can also see the services. Over here on the log, I can see any errors that has occurred. And on the history tab, I can see who deployed the solution. The server also has other options such as upload solution. If you don't want to upload a solution directly from the LINX designer, you can do it over here. You can, in LINX designer, say save my solution as a zip file and then upload that zip file directly onto the server. You can also do user maintenance, license maintenance, check the resources, which solutions are using what amount of resources, look at the server log, the host log, and update the LINX server. Now that we've had a look at all of the LINX fundamentals, let's build a solution together to see how each one of these elements will work together. The solution we're going to be building is a very simple integration solution that will call an API every 15 minutes. It will then take that data and read it into a database. For the solution, I'm going to create a solution from scratch. To do this, I'm going to click on the Create Solution button. Now we have an empty solution so that we can start. I know that we're going to do two things in this specific solution. We're going to interact with databases and we're going to pull data from a REST API. So to do that, I'm going to add those two plugins. I'm going to click on the Add Plugin button, add the database plugin, as well as the REST plugin. Once those have been added to my solution, I'm now free to access the specific functionality of each plugin. I know that we're going to use the call REST endpoint function to call the API, but before we do that, let's start off by doing a little bit of organization. Let's rename this function to be called getData so that we can easily know what the specific function does. Now in the central canvas of this thing, I'm going to drag and drop the call REST endpoint function. And over here, we now have multiple properties that we can set. Immediately we know that we need to paste in a URL. For the specific URL, I'm going to use an API endpoint, one that I already have that's configured. This specific endpoint does not need any authentication, and there's nothing strange or complex about it. We're going to leave the method as get. There's no query string parameters, and no body needs to be passed in. For now, let's leave the output type as string. To see what the response looks like when I'm going to call this endpoint, let's debug our solution. Going to click on debug, going to click on start, and then step over. On the right hand side here, we can now see the response body coming back. Now, this is a string, and it's not very usable in its current format. What we would ideally like is for this to be a type. So to handle it as a type, we're going to have to import a type. To do this, there are two different ways. Either we can copy this specific JSON directly from the response body, or we can get the response body from the documentation of the specific API. This is the Swagger documentation for this API, and this is the specific JSON object that will be coming as a response body. I'm going to copy this. Let's stop our debugging and let's add a new folder. Let's call this folder types, because we're going to store our types in here. I'm going to right click on types and then say import type. Let's call this product, because we know we're going to be receiving a list of products. Paste that in here. Important to note that when we paste the object in here, it has a list. But when it's created in links, that item is just created as a type without the list. So this means that we will have to handle the response body coming in as a list of products. I'm just going to save that. Now, what we can do is we can set the output type. I'm just going to click drop down there. We know we're receiving a list, and we know that list is of type products. There we go. Save that. Now if I debug this again, start, step over, the response body comes back with 3 items, and all 3 of them are products. Now this is much more manageable, and we can use this downstream in our function. I'm going to stop this. Now for the next thing that we need to do is we need to insert this data into a database. To do this, I'm going to use the database plugin. Specifically, I'm going to use the execute SQL component. This allows us to execute a piece of SQL code. I'm going to drag this in here. First of all, we need to say what database it is. I'm going to connect to a SQL Server database. For our connection string, instead of putting in the connection string over here, I'm going to create a setting for our connection string. To do this, I'm going to click on the settings button. Let's create a new one called database connection. We're going to make our string as a secret, and then add our connection string in. We could, if we wanted to, add in a connection string by using the connection string builder over here and testing our connection string. But since it's already available for us in the settings, we can now just click on the drop down button, click on settings, and select that database connection. Next up is to actually create the SQL. I'm going to click on the ellipsis here, and over here is our SQL builder. Right next to the variables over there, we have objects. If your database allows these type of interactions, we'll be able to see all of the database, the tables inside of our database. We're going to be using the products API import. I'm going to right click on this and generate insert. Now over here we have the ID, product name, price, all of these are available, and we want to add in the values in there. But right now, the values coming from our response body is a list, which means that we won't really be able to interact with it. So I'm going to save this, and to interact with the list, we're going to use what we call a for each. I'm going to drag this up just above the execute SQL component. Then the list that we want to loop through is going to be the list that is coming from our response body. And I'm going to drag the execute SQL component inside of this list so that we will now be able to access each one of the properties coming from this response body. I'm going to open my SQL up again, and now we will be able to access each individual field inside of our list. So for the ID, I'm just going to remove that because we are using identity insert inside of our table. Then the product name is the first thing that we need to add. I'm going to double click on it. Next up is the price, followed by the quantity available, followed by added by. We can hard code this to links. And the date added will be our specific system date. So I'm going to use the current date time. There we go, save that. Now, if we want to see this in action, we can deplug it again. Step over, go into the for each loop, there's our product, and we insert this. Now, if there are any errors inside of our SQL, we'll be able to see this here in this debugger. For example, we have over here, incorrect syntax near comma. What this means is that there is an incorrect syntax there. And in our SQL script, we can see that I did not remove the comma from our column list. So I can just go back in here, remove the comma there. We could have ideally also tested our SQL script, but I did not do that. If you're going to do that, click on test, add in the values over here, and then execute SQL. Let's save this. Let's debug it again, start it, run over it. Inside of the loop, there's our test. And the insertion is done. 1, 2, 3 products, and that's it. So now we've created a very simple function that will get our data. The next part of the solution is to actually add some orchestration to it, namely add a timer that will execute every 15 minutes. To do this, I'm going to use underneath the utilities plugin, I'm going to use the timer service, drag that into my Solution Explorer. Over here, we need to set the time. I'm going to leave it on interval. We're going to set the time to 15 minutes, every 15 minutes, every day. We could set some more specific time properties here if we wanted to, but I'm going to leave that as every day. And inside of our timer event, we now need to add the functionality that needs to be executed. Since we've already created a function called getData that will get the data from the API and pass it into a database, I'm simply going to drag that function in here. Now this perfectly shows how reusable functions can be. You can use functions inside of other functions, inside of services. You could also, if you wanted to, create a recursive function, but that is a little bit inadvisable unless you have some very specific logic that will not cause it to go into an infinite loop. So that's basically it. Now we've created a very simple solution that will run every 15 minutes. It will extract data from an API and then put that data inside of a database. The last part then is to deploy the solution onto a Lynx server where it will be hosted. Let's start off by giving the solution a recognizable name so that we can easily maintain it. To do this, I'm going to click on the solution at the top there. Let's call it my solution. Or rather, let's be more specific. Let's call it my API solution. And now we need to save the solution. To do this, you're going to click on save, select where you want to save it, and then the save files will be created. Important to note that these solution files can be uploaded to something like Bitbucket or GitHub. Next up, we need to deploy. To do this, click on the deploy button. Initially, you will have to set up a server, or you will have a list of servers over here. I'm just going to select my local server, and then I'm going to click on deploy and open server. This will now deploy the solution onto my Lynx server, and it will open the server for me when it's ready. Once ready, you will see this login page. This is the login page to the Lynx server UI. We can click on login, and then you will see the Lynx server UI. Each one of these items are a Lynx solution that is currently running on the Lynx server. Over here is our My API solution. I can click on this solution, and we can see that our timer has not started yet. When I click on, the timer will start and the solution will execute as we set it up, meaning that the getData function will execute every 15 minutes. And that's basically how you will deploy your solutions onto a Lynx server. Now that we've taken a look at the fundamentals, let's discuss some design principles. Lynx allows for flexible design and development, meaning you can implement solutions however you choose. Because of its programming-like approach, there are many ways to solve a problem. We do, however, recommend that a solution is developed with maintainability, readability, and scalability in mind. Here are some principles that we feel are best practices when designing and implementing a Lynx solution. Ask yourself the question, is my solution readable, maintainable, efficient, and debuggable? Readable means that does it make sense when reading through it, and can I quickly understand what's going on when I ever need to come back to my solution? This can be done by using descriptive names and breaking down functions into their smallest, most manageable parts. Maintainable. Will the solution be easy to maintain and enhance? This can also be done by breaking down functions into their smallest, most reusable parts. Efficiency. Lynx, like any programming language, puts you in control of how you utilize resources. Some executions will be more resource intense than others. Ensure that your functions use resources that you have available efficiently. And finally, debuggable. Can I easily and quickly debug the solution and find the root of an error when it occurs? Again, this can be done by breaking down functions into their smallest, most reusable parts, but naming and organization will also play a core role here. Make sure that functions are placed in correct folders, that types are easily accessible and distinguishable. Thank you for watching this Lynx fundamental training video. If you have any further questions, please feel free to consult the documentation or reach out to us on the Lynx community site, accessible via the Lynx website. The Lynx community site is the perfect place to ask questions, see questions that have already been asked and answered, and even to give tips and tricks.